some problem solvings of chemical reaction engineering or chemical reaction kinetics. So before going further, we need to understand the different formulas, okay, by the rate law and the integrated rate law, okay? And of course, the concept of the determination of the initial rates or method of initial rates. When we speak about method of initial rates, meaning to say it is a specific method to distinguish and to determine the reactive concentration order of each reactant. Okay, reactant order. Okay, so we need to determine each reactant reaction order. Okay, as I discussed yesterday, we let a small letter n as our order. Okay, the same as n as our total order. But it depends on our attack of our problem solving. If we mean that overall reaction order, still a simple letter n, small letter n will do, but we should sum the exponents of each reactant concentration. For example, A plus B plus C. Ganun siya. A is a concentration, okay, and B is also a concentration, and C is also a concentration, meaning to say reactants concentration. Okay, so our rate law for that will be K, small letter K. If you have a blank sheet of paper, then you can write it out. Because I don't write in my, blank sheet of paper because I have so many scratch papers. Oh my God. Okay, it's R represents rate law. Okay, or small letter R. Okay, we preferred small letter R, because other reference books and other reference materials or any sources of information out there, they represent the R as capital R for the rate law. But here, small letter R, let's agree so that we can easily understand. Okay. Then R is equals to K, small letter K, not big K, then times bracket A raised to the power X times bracket B raised to the power Y times C raised to the bracket Z, X, Y, Z. Okay, ganon. Exponents are X, Y, Z. It depends on you what particular letters you will assign for each reactant concentration. Okay, the important is you really have the basic knowledge how to determine each reaction order. Okay, it's just gonna be like that. Okay, then for the formulas of the half-life is very also important. And then our focus mainly is for zero, okay, rate order, okay, zero first and second order of reaction only. Again, zero order reaction, first order reaction, and second only. Okay, because there are also third order reaction, 4, 5, 6, blah blah blah, but there's no such specific formulas for that. But there are also questions like that. Okay, especially given the rate equation constant or the rate constant. It's in there that we can also determine the reaction order. Okay, like that. So before going further, let's have a quick presentation of formulas that we'll be able to use, because it's not also good that I cannot present to you what are those basic formulas, right? Okay. But in this chemical reaction kinetics is more on analysis, okay? It's more analysis because there's data given, okay? Laboratory tests data, experiment 1, 2, 3, 4, 5, 6. And you have to analyze from the initial concentration of the reactants, and then final reaction of the concentration of the reactant. Like that only, you have to establish, increase for a factor of like this, what will happen to your rate law, ganon siya. And then you have to apply the formulas after you have analyzed. For example, the rate law of this will be like this. If we try to increase the concentration reactant A to 2, ganon. then you can obtain the reaction order. Usually in the problems, the reaction order are not specified, but there are also problems that the reaction order are specified already, so it's very easy to compute for the required, okay, what is being asked for the problem. Okay, but sometimes we need to identify also the integrated.
The Bluetooth device is ready to pair.
Integrated, rate low and the original rate low. Or shall we say the rate low only? Okay, I don't have my pencil right now. Okay. Okay, this will take a long time because I have to present all the formulas first before going to the problem solving. Actually, I have 9 questions. Some questions came out really in the actual Bachelor of Science Chemical Engineering Board examination. Okay, then it being compiled and then mixed with other sources also. Okay, other sources of problem solvings also. For example, in the YT videos, okay, and in other first websites also, the Wikipedia, source of information, like this. I have to compile it, okay, and then...
The Bluetooth device is connected successfully.
Oh my gosh. And mix it with simple only, okay? I don't like difficult. Nobody wants difficult problems, right? Even us. We don't want difficult problems in our lives. The same thing as that. We don't like also difficult problems in our problem solving in examination. Nobody wants that. Of course. And then if there is, then we'll try our best to solve it out. Okay? But really, I choose not the difficult one. Okay? Wait for a moment. Charot. Okay. Like that. So, I have to establish the signal in my laptop. Okay? And then, I have to use this also. After this, I'll be shifting to the laptop live streaming. Okay? Oh my gosh. So, here it is. Okay. So, it depends talaga siya if there are a lot of data to be presented. And then if there's no change, then don't focus on those situations or data that has no changes, because chemical reaction kinetics focusing on the reaction rate, the change in the reaction rate, and to determine how fast or slow a chemical reaction. Just only like that. But how can we determine if it is fast or slow if there's no change from your reactant concentration? So common sense, right? Do not focus on the no changing. Focus on the initial concentrations that have changes. And then with corresponding rate low. Ganon. Okay? Our units will be dependent also upon incorporating each unit. Do not memorize the unit because it depends on the situation. When you insert and you cancel that one, something like that. So we don't have to memorize. We need only to insert, cancel, and what's left, that's become a unit for the particular rate low. Could it be zero order, first order, second order, so on and so forth. Okay? Like that. Shout out to Engineer Anis Pacamalan, the head of Chemical Engineering Department of Cebu Institute of Technology University. Shout out to Engineer Concordia Bacalso, our mentor and instructor for this subject when I was in college, Chemical Reaction Kinetics. Okay. Shout out to Engineer Ana Morel Salending, Engineer Rio Merel, Engineer Timoteo Idolantes, Engineer Ivy Adlawan, Engineer Rainier Estrada, Engineer Gregory Danilo Daclan, Engineer Judy Lamusao, Engineer Stephen Flores, Engineer Raul Raymond Capono. Okay, most outstanding students of the Philippines, something like that. Okay, award. Okay, and Engineer Dominador Canyeda. Shout out sa mga chemical engineers. Okay. So, please forgive me if I cannot present very well my discussion. This is only, this is only sharing a little bit of information. Okay, because, guys, that's 25 years ago, right? So, you cannot expect me to be perfect for this presentation and discussion of this chemical reaction kinetics. All I can share to you is the basic foundation for this reaction kinetics. Okay? I'm done with the basic theories and principles I discussed last 2 days ago, right? Okay, then we will focus now for the problem solving. But before that, I will be able to present to you the formulas, okay? Like this. Oh, where's the blank sheet of paper? Charot. Oh, ubus na siya. Okay. Cast ito bond papers. Wow. Okay, I have to get new sheet of paper here. Oh my gosh. Okay, shout out to our chemical engineering students all over the world. All over the world talaga. Yes, and also shout out to all BS chemistry students, BS pharmacy students, BS medical technology students, BS forensic science students, BS biology students, BS biochemistry students, BS in physics students, okay, BS in nuclear engineering, I think so have in University of the Philippines, Diliman, okay, special course, okay, because this topic is really applicable to those students that taking up more sciences, related to sciences courses only, okay. If you think your course is not really belongs to sciences, for example, business administration, psychology, education, College of Arts and Sciences, okay, then you can skip that video because this is not for you. But if you really wanted also to learn, because all courses in institutions and universities all over the world have chemistry subjects as your idea also, then you can stay tuned, okay, and listen to me also if you want to. You have the option. Okay, you have the right, you have the complete right to do so. Okay, but this is preferably for the students that have sciences courses related course, okay, like that. Okay, so especially these pharmacies, so many chemistry there, okay. These pharmacists, okay, they're studying the composition and ingredients of antibiotics, medicines, syrups, like that, and everything for the epidemiology, okay, the study of the disease controls and prevention. Okay, so that's their focus, and they need to analyze what are the raw materials in producing these medicines, and of course, to identify what is really the chemical reactions out of those raw materials to produce the desired products. In order, very helpful to heal and to treat and to cure those patients in the hospitals. Something like that, okay? And also for the, forensic science also, they have to study the samples. When somebody died in a crime, forensic science students will investigate the samples, really. The samples of the bone, the samples of the urine, the samples of the semen, and everything. And have to study also the chemical reactions for that. And then you have to identify the DNA, deoxyribonucleic acid, okay, deoxyribonucleic acid, and the ribonucleic acid RNA. Okay, that's for the genetic information for individual inheritance and hereditary traits. Ganon. So that we can easily identify who killed to that particular person, and then it will be used in the investigation. Okay, in a crime investigation, something like that. Those are forensic students, BS forensic science. They study a lot of chemistry also. Okay, not only for chemical engineering and BS Chem, okay, like that. So, going back to chemical reaction kinetics. Okay, I have to put the formulas here. Okay, but it depends on the focus, because they are more on the clinical side. Okay, clinical chemistry. Okay, but chemical engineering focusing more on the process side. Okay, the plant, the industries, and all other chemical process industries, or physical and chemical separation processes. We are not more on the medicine side, okay, but we can still adopt because we studied also about that. But that is not our focus and concentration, but we have also knowledge for that. Okay? The same thing also with the pharmacy students, medical students. You can also work also in the process because they also understand chemistry, right? So it's vice versa. Okay, that means versatility counts or flexibility counts, okay, in terms of knowledge. It's not only through specialization, right? Even if you are not related to science, you can still understand for this. If you want to, if you really want to learn, right? So going back to the formulas of chemical reaction kinetics, okay? Like this, going back, okay? Sorry, ha, I'm very, very fast talking. Okay. Okay. Like this, chemical reaction kinetics formulas, okay? Memorize, okay? Because we don't have time to derive, okay? And then if there are problems that you cannot really understand what is the specific formula to be used, and that's the time you will compile and correlate all the formulas you learned and derive on the spot. Okay, during the examination, if you don't know what is specific formulas for that, right? Because some problems are like that also. Though not all, but some requires critical thinking. Okay, meaning to say you have to connect the dots of different formulas in different subjects. Okay, and then only one question. Okay, something like that. And you need to be, alert for that, attentive for that also. Okay, number one, zero order sa taha. Okay, ganon. Okay, zero order reaction. Ganon. Zero order reaction. Okay. Okay, in zero order reaction, A will produce B only, like this. Okay? Zero order reaction. Reactant A will produce product B, then there's a decrease of the rate of the A throughout time period. Okay? As the time increases, the concentration of A will decrease. Okay? Meaning to say, they have inversely proportional relationship with each other. So, concentration of A is always negative. Okay? Concentration of B is always positive. Okay. Then if we put our rate low, small r, so it will become r is equals to k, capital A, raised to the power 0, because this is zero order. Right? Okay. Anything raised to the power 0, algebra, is equals to 1. Okay, so, meaning to say, the initial concentration in a zero-order reaction will not matter. Again, if the question says, okay, what will happen to the initial concentration in a zero-order reaction? So, you said nothing or none, because in the zero order, there's no initial concentration relationship. It will be cancelled automatically because anything raised to the power 0 will be equal to 1. So, your rate law of chemical reaction will simply equal to your rate equation constant. Okay, memorize this. Okay, chemical engineering students, memorize this also. Okay, in zero order reaction, okay, your rate law or rate of chemical reaction will be equal to K only because the initial concentration will become 1 because anything raised to the power 0 is equals to 1. Okay? So meaning to say, zero order reaction is a chemical reaction in which it is not dependent on the reaction concentration of the reactant. Ganon. Okay. This is zero order. First order. Okay. So in the first order, ganon. Okay, our rate law will be using the same equation A to B. Okay, R is equals to K, A raised to the power 1. This one. The exponent will represent the order, the reaction order, okay? Like that. So, anything raised to the power 1 is still the same. Okay, so variable. So this is R is equals to Ka only. Okay? For the first order. Charot. Okay? So K is equals to A. K times A. And this is our R for the first order reaction. So, this one. Tanawa siya pag-ayo. Uy nga. Okay? Very easy, right? Charot. R is equals to K times capital A. Capital A is the reactant concentration. Okay? Like that. So, it is in the first order reaction that it is dependent on the reaction concentration, our rate law. Okay, so meaning to say, in the first order reaction, our rate of chemical reaction is dependent, okay, for the reaction of the rate constant. Okay, so there's a relationship for that. Okay, like that. So, and zero order is not dependent, okay? Just bear that in mind. So, 1, 2, 3, all will be dependent except for zero. Okay? Zero order. Okay, something like that. For the second order, ano siya? Panawasan ninyo, oh. Okay? Ganon. So, n is equals to lata, second order. Okay. R K raised to the power A2. Okay? Ganon. Muna siya ang N2. Ganon siya. Oh, tara. Okay? R is equals to K, A raised to the power 2. Because second order, N is in the upper portion. Ganon. So, R is equals to K times A raised to the power 2. So, this is for the reaction A to B. How about in the reaction A plus B plus C? There's a lot of multiple reactants. Okay, so this is gonna be the solution. So rate law is equals to K A raised to the power. Let X is the value of order in concentration A. And like that. X. Algebra talaga, oy. Okay? R. And let Y is the value or the exponent of the concentration B. And this is the order. And C, it depends on you if you're going to A to Z. It doesn't matter. Okay? You still find the answer, but it's not ideal anymore to have so many concentrations in a chemical reaction. Okay? Like the C raised to the power Z. So, X, Y, Z are the reaction order. Okay? X, Y, Z are the reaction order N. Okay? Like this. Ganon. X, Y, Z reaction order N. And the definition will be the overall reaction order. So overall reaction order will be X plus Y plus Z. Ganon. Overall reaction order is the sum of all exponents of each reactant concentration A, B, and C. If the question will say, what is the overall reaction order? It's not the same as questioning the reaction order of concentration A, concentration B, concentration C. Okay? Like that. Because that is total or overall reaction order. So this is for multiple chemical reactions, the rate law of multiple chemical reactions. Or shall we say, a minimum of A and B only. Okay? But you can still have so many reactant concentrations if you want. Okay? Like, it depends on your experimentation of your data that you come up with your initial concentration, ganon. Okay, so let's try to analyze later for the tables. Okay, that would be enough. Oh, no, it's not yet. Okay, since we are discussing already the nuclear chemical reactions or nuclear chemistry, right, regarding the half-life of certain elements during nuclear transmutation, right? So, nuclear transmutation, you remember the definition? It is a process or activity by conversion or changing one form of element into various form of elements. Okay, or it could be stated differently, but the same principle. It is a process of conversion and changing of original form of element, okay, or naturally occurring element to produce an artificially prepared elements in various forms. Okay, ganun siya. Just memorize the definition, okay, and then do not focus on the terms. You can have your own terms if you wanted to. Just understand only, okay? Like that, because there's a specific terms in the textbooks, and then do not limit to that particular terms. You can have your own, okay, like that. So that's the technique of memorization. Okay, that's nuclear transmutation. Since nuclear transmutation or nuclear chemical reactions still a part or involved in this chemical reaction engineering or chemical reaction kinetics, then we have also half-life formulas for this. For example, in a zero order reaction, okay, we have the half-life. Okay? You will say, Sotero, why you did not derive? I should not derive because it will take me a longer time to do it. Really. Okay? So, this is n is equals to 0. Even the scientists, it takes years to come up with a final formula. Okay? So, n is equals to 0 for the first order. Ganon. Tanawa siya. Okay. Half-life, t raised to the power 1/2 is our symbol. Okay? So, half-life is equals to t over 2 to the 1/2. Ganon. Okay? Ganon siya. Okay? Then, our half-life for zero order, we have initial concentration of A. A siya because we need to start from capital A. A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, N, V, W, X, Y, and Z. Boys and girls can sing with me. Come and sing the ABC. Okay? So we need to start with letter A, capital A. That's why we always say initial concentration of A. We start from the first, not letter Z. Okay? So, capital A, subscript 0. So the subscript 0 is simply a term initial, okay, or let us say original, okay, or at time is equals to 0. Okay, again, the letter O at the subscript of the capital A concentration or reactant, the same as initial, 0, or letter O. Letter O because means original concentration, meaning it start there, not yet reacting. Original, okay. And it is also 0 because it doesn't react to another substance. So at time is equals to 0, meaning the reaction did not proceed yet. Or it is an initial stage or initial state. Okay, state and stage is just the same, ha? Okay, so over, ganon, 2K. O, darama na siya. Okay. For the zero order, the half-life will be equal to the initial concentration of A over the 2K. K is the rate constant or rate equation constant or rate reaction constant. Okay? Ganon. Okay. So for the first order, okay, first order is equal to T raised to the power 1/2 is equals to ln 2 over K. Hala. Reverse na ni siya. I'll give you the theory behind this. Okay. What did you notice in the half-life reaction of first order when n is equals to 0? Is T raised to the power 1/2 is equals to ln to logarithmic, right? ln in the scientific calculator. Okay? Over K. What happened? There's no initial concentration anymore. So, in the computation of the half-life process, in the first order reaction, it is not dependent on the initial concentration. Okay? So sometimes the question will confuse you. You'll say, what is the half-life for this? The initial concentration for this? But it is not. Because in the half-life process of the first order, initial concentrations are not mentioned in the formula. Okay? So it's just deceiving you. Okay? If the problem will goes like that. Okay? Again, if the problem or the question will state to ask or find the half-life, then mentioning the initial concentration on the problem, it is not correct. Because in the first order reaction, there's no issue in the initial concentration. It is not dependent on the initial concentration. Unlike the zero order, in the rate law chemical reaction also, there's no issue of the initial concentration. Okay, so you have to memorize what is not dependent, what is dependent, like that. If you have the formula, then you can easily understand, okay? Like this, because the half-life process of the first order reaction, m is equals to 1, is equals to ln2 over k. Okay, for the first order reaction. And now we go to the second order reaction. N is equals to 2. Ganon. Oh my gosh, we got it. Okay. So T 1/2. Makalingaw siya because you have to analyze, right? T 1/2 is equals to 1 over EOK. Makalingaw siya na makalagot, something like that. Okay? And then makalibog. Okay? But, you know, we can manage. Okay? Like this. Now, in the second order reaction, T 1/2, 1 over EO times T. This second order reaction is the reverse for this, okay? Zero order, but there's no toe already. There's no number 2 already. It's removed. Okay? Like this. Okay, so AOK na lang siya. So, it's in the denominator. Now, I will say that the initial concentration of the second order is not the same with a zero order. Okay, if the question will say like this, what will happen to the initial concentration in the second order reaction if the half-life will decrease? Something like that. So, your initial concentration will go high. Okay? But it is not true in the zero order reaction. Because if you increase the half-life, okay, it will also increase the initial concentration. So, you know, sometimes, oh my gosh, why like this? All are half-life, but the relationship of initial concentration is not the same. Okay, because they are different chemical reactions. Okay, and they have different order. It matters a lot. Okay, if we have different reaction orders. Okay? Like that. So sometimes in chemistry alone, you will get the half-life, right? You can still use this one. Okay? But there are also problems that you can only analyze also. For example, if the elements start with this and after the half-life, after how many seconds, and after that how many seconds, you have to understand that it's only half until it will reach to that particular time at 48 minutes baron. Okay, you have to determine the gap of the half, ganon. Okay, 30 seconds, half is 15. So after 15 seconds, what will happen to this element A? Ganon. And after 30 seconds, what will happen to this element A? Again. And after 45 plus 15, right, what will happen to that element A? So we can solve also through that analysis. Okay, but you can also apply this formula. Okay, this one. But the problem of this applying with this formula, we cannot understand really if there's a lot of, you know, a lot of reactants. The best way is to solve by analysis, okay? But if you think that that is only A producing B, then you have to use this. Okay, but if there's a lot of reactants, then you cannot understand also. Where should I use this? Ganon. Okay? So, you have to be clever enough. Something like that. Okay? So, these are the formulas to be used. Okay. Ganon. So, for the value of K. Okay? Like, for the value of K na ta. Okay? Rate reaction constant. Okay? For the first order, charot. Okay. For the first order, we have ang K niya. Oh my gosh. Grabe naman yan. This is very important so that we can determine the units. Okay? In our daytime experiment, there's a lot of units there. Then it will correspond to the K. Then we can determine also the reaction order even if it was not mentioned in our problem. Okay? That's the basis, the rate constant. Okay? Like that. So by the way pala, the rate of constant reaction of the reaction rate, or K, is always increasing when the initial concentration is also increasing. So directly proportional with each other, except for zero order. Okay? Like for example, if this concentration A will become higher, then our rate also will become higher, and the like that. Okay, the rest will follow. Okay? Because it is directly proportional with each other, something like that. Okay, if you increase the concentration, you will also increase your rate of chemical reaction, something like that. So just have this formula, my friend, for this one, the rate law, and then you can determine, okay, through the inversely proportional with each other, because sometimes I may be wrong in talking. It's better to understand the formula. Okay, if it's in the denominator, and then it's inversely proportional. And if it is in the numerator, that is directly proportional. Or if it is in the numerator, then it is dependent with each other. And then if it's in the denominator, that is independent with each other. Sometimes, because if I keep on talking, maybe I missed something, it will be reversed. Okay, sometimes, okay, our memory is filled. Okay, like that. So just focus on the formula that I presented to you also. Okay? Going back to this. Ano ba yun? Letter K, right? K is the rate equation constant. Okay. So N is equals to 0. Our K is equals to capital M, 1 minus N, T negative 1. Actually, difficult siya. Wow. Difficult siya, right? Okay. Difficult siya in a sense that we need to memorize this. Okay? It's not also very, it's not logical to keep on driving, my God, and then all your time will be finished. Okay? Especially in examination, time limited. Okay? Memorize this. K is equals to capital M raised to the power 1 minus N times T raised to the power negative 1. Oh my goodness. Okay, N is the reaction order. Since we are dealing with zero order, substitute the 0 in the N. Okay, so M 1 minus 0, T negative 1. So M raised to the power 1, T negative 1, so equal to M T negative 1, or M over T. Okay, this one, just basic mathematics in algebra, right? Okay, like this. Substitute, and then bingo, you can have the M over time. And then, since the standard for this is second, we have molarity, capital M over second. So this is our K unit in the zero order reaction. Okay. Our rate equation constant, or our reaction rate constant unit in a zero order reaction, is equal to the molarity over second, unless otherwise not specified. Okay? We go back to the original. Okay? Because sometimes it was not mentioned, so it is supposedly using S already, second. It was not mentioned in the problem, use automatically the seconds. Or it depends on your data in the experiment, something like that. Okay? So, like this. And then for the first order, kani siya nga formula, okay? Oh my gosh. So, K is equals to M, 1 minus 1, T negative 1. So, M is equals to 0, then T negative 1. So, anything raised to the power 0 is equals to 1. So T negative 1 is equals to 1 over T is equals to 1 over seconds. Oh my goodness. Okay. Like this. K is equals to M raised to the power 1 minus 1 times T raised to the power negative 1. Then substitute the value of N is equals to 1. Then bingo. You can solve for the value of K, which is 1 over T. Then standard time unit is seconds, 1 over second. So if it is mentioned 1 over second in a problem, then automatically the problem deals with first order reaction. Okay? So that's the technique. Do not wait for the zero order to be mentioned in the problem. Okay? That's become a problem. Okay? So, in the second order, N is equals to 2. Okay, so K is equals to N 1 minus 2 T negative 1. Okay, K is equals to N negative 1 T negative 1. So K is equals to 1 over M and T. Then K is equals to 1 second. Okay, like this. This one. Okay. 1 minus 2, negative 1. This one. This one. The unit of the K for the second order fraction. 1 over M and second. Okay? Just substitute for the formula. K is equals to capital N raised to the power 1 minus N times T exponent to the negative 1 and bingo. You can solve for the value of K. Okay? K is the rate equation constant or reaction rate constant. Okay? Like that. So you can determine really the order for that. It's enough. I show you the rate equation constant, the rate law, the half-life. Okay? And I will show you the slope. Slope. Okay? If you remember in algebra, we have the formula, right? Y is equals to mx plus b. Okay? And then you have the quadratic equation. Okay? Negative b, like that, right? Negative b plus and minus the square root of negative b raised to the power 2 or positive b. I'm not really sure, but let's have positive. Okay, negative b plus and minus square root of b raised to the power 2 minus 4ac. A, b, and c are the constant in the equation y is equals to mxb. Okay, this one. mx plus bdi, sorry. This one. Okay, this is in algebra, right? Y is equals to mx plus b. Okay, so your m there is the slope, just equal to k in this topic of the rate law. Okay, m is the k. Then, for example, find the value of m, and then you are not used to, okay, charot. Okay, but the question will just assuming that the students know already, and the question will say, what is the value of m? Charot. And that is also the k pala. So, wala, yabo na. Okay? Because m is equal to k. Okay? Like that. Good if the problem will also ask what is the value of k. But the students are dependent on the value of m because that is the always formula showing in their discussion. Okay? But when the problem in the examination will state another letter, but same formula, they will be confused already because they did not meet that letter in the slope formula. Okay? That's why I'm telling that is only representation. Okay? Here. But in here, m is the usual attack in algebra. So y is equals to mx plus b. There's no such other letter for that. M is always the k. I never see textbooks that using m as q. Okay? Or any other letter. It's always m in the slope. Okay? Like that. And then if you have a graph, okay, C and the temperature, concentration and the temperature, then in the second order, this will be your graph, a straight line. Okay? Like this. So the slope now, if you try to connect the data from y-axis and the x-axis, your slope now will be equal to m or k, ha? Ajud mo kalibog. M is equal to k na jud siya. Okay? Forever. So m is equals to k is equals to y2 minus y1 x2 minus x1. Okay. Why, Sir Sotero, why you put y2 and x? Because for the purpose of the graphical representation only. But this y is the vertical y-axis and x is the horizontal x-axis. So y represents the concentration and x represents the time. Okay? And then substitute the concentration in y and time in x. It's just only the variable, right? Actually, you can have this as a also if you wanted to. Okay? This is only representation. But this is the standard formula for finding a slope in algebra. Okay, m is equals to y2 minus y1 over x2 minus x1. Then using the formula y is equals to mx plus b. M is equals to the k we are referring to as the rate equation constant for this particular topic, chemical reaction kinetics. Okay, k is equals to m already, ha? Okay, like that. So sometimes the problem also will give the different graphs and you have to identify what is this order about. Ganon. Then if you familiarize the graph, then you can answer. Okay. The second order is the only different. The line will goes to the right, but the other one is the reverse. The arrow will go down, but straight line, the zero and the first order. Okay. Actually, we don't have to memorize that one. You have to plot one by one according to the data of the initial concentration, but we don't have the data yet. Okay? We don't have the experimentation yet in the laboratory to show what are the initial concentrations that we are going to tabulate. Okay, this is really, but this is just the same. When you plot those initial concentrations, you can obtain the graph like this. Okay? Any questions so far? Okay, by the way, in the zero order reaction, our K or our slope or our rate equation constant C is just the same, right? K and N, then rate equation constant is the slope. Sometimes it will be used interchangeably, right? So, problem really. Okay, so K is equals to N. So we need to say the slope is equals to K, right? And the K is the rate equation constant. Oh my goodness. Okay, like that. So the K is negative in zero order. The K in the first order is negative. And the K in the second order is positive. So bear that in mind that only the second order has negative K or negative slope. Okay, it will matter because if you substitute the concentration, so negative indicates that it has a decreasing concentration. Okay, so it's not the same as positive concentration. So very, very big difference. So that's why you need to memorize that only second order reaction has a negative slope and a negative rate equation constant, which is represented as a small letter K. K is equals to N. Okay, something like that. Okay? Any questions so far? Like this. Okay? Klaro man siya, di ba? Okay. So, let's stop for a while because I have low bat mobile phone. And let's come back for the part 2. And then I have now the different examples of the problems and we will solve. Oh my gosh. Okay. Hello, God bless everybody. If you like this video, you can click the notification bell for some news updates of I am a singer eternal voice and subscribe also my YT channel if you are not yet subscribing. Okay, you can like, you can comment or anything you want to. Okay, bye bye. See you later.